Okay, the first 6 questions say simply to simplify. Simplify. What does simplify means? It means number 1, it means no parentheses. Secondly, it means, unless you have to put them in, but usually no parentheses, okay? Secondly, it means reduce fractions. To reduce fractions, you have to know how to factor. Okay? And when you can cancel. Okay? To do that, let's take some examples. Now, let's take a look at what these examples on these problems were. We had, first of all, number 1 just had some polynomial up here over top of another polynomial. You had to factor the numerator and denominator and cancel out. Okay? So, this problem was 7y cubed minus 14y squared all over y minus 2. If I were to, y minus 2 is prime. I can't factor that. However, up on the numerator, I can take something out. There's a 7 common to both of these, so I can take a 7 out. There is a y squared common to both of these. So I have 7y squared. And now what am I going to multiply 7y squared by to get 7y cubed? It's basically undistributing here. So I'm just going to multiply it by y and then minus 2 over y minus 2. And now that I have multiplication implied here, I can cancel out these and I just get 7y squared.
You could do that little dividing thing too.
Yes, you could. You could also do this. I understand what you're saying, Weston. What you could have done is you could have said, this numerator is being divided by this denominator, right? So you could have done this with long division. That wasn't really the way you were supposed to do it, but that's all right. 14y squared divided by y minus 2, right? So you take the y times 7y squared, right? Gives you 7y cubed. And then minus 2 gives you minus 14y squared. Okay? So you end up with the same thing. Okay? So when you have a fraction like that, you can also do it either way. Now this way only works. This way only works when the numerator exponent is greater than the denominator exponent. Okay?
What if it's not?
If it's not, you have to rely on your distributive property.
It's the same.
Huh? If it's the same, you could probably do it that way too. Okay? So now, all right, the next one is also a fraction, so you could do that either way. Okay, let's say you wanted to know that this was the same. But really, don't you think that 4u squared minus 25, you should recognize this? Right? 2u squared minus 9u minus 35. What I like to do is, to me that long division is a long process. However, factoring to me, I use whatever way is quickest. Does anyone recognize this numerator?
Times 2.
Yeah, it's the difference of 2 perfect squares, isn't it? Okay, first we always take out the greatest common monomial. There is no monomial common to 4 and 25. So I'm going to factor it into 2u plus 5 times 2u minus 5. Okay? And now down here, I'm going to factor this one just by doing it like this. Okay? I need 2 things that give me 2u squared, 2u and u. 2 numbers that give me 35, negative 35, whose difference is 9. So, okay, so and one of them is going to be multiplied by 2. So, in that case, what did we get?
6 and 5.
6 and 5? 7 and 5, right? 7, 14, 7 here would give me 14u this way. 5 this way would give me the 5u, right? And I need 14 to be negative, right? And 5u to be positive. So now I have 2u plus 5 times u minus 7. And the 2u plus 5 cancels out up into here. And you just end up with 2u minus 5 over u minus 7. Okay?
Oh, I see what you're on.
Oh.
I got the signs mixed up.
Okay. The next two problems involve multiplication. When you have two fractions that are multiplied with a dot in between, okay, you're going to multiply straight across the numerator and straight across the denominator after you do what? After you bow tie cancel. Now, bow tie cancel means I can cancel along any of those lines. Okay? Now, division, however, you've got the next two problems that are divided when you have this symbol between them. Okay? Let me put some letters in here, just so you know what I'm going to do. I'm going to take the first fraction and leave it alone, and I'm going to change the sign to multiplication, and I'm going to take the reciprocal of the c over d, which makes it d over c. And at this point, it becomes the same thing as this problem over there. Okay? So now if you didn't remember how to do that, let's take these examples on this problem. 3a to the 4th over ab squared times 4ab squared over 21. Make sure that I'm copying these right. ab squared, okay, now let's take a look. I'm multiplying so I can go directly to my bow tie cancel, right? So draw your bow tie in there. Okay? If you want to look at your numbers first, look at your numbers first. Okay? 3 goes into 3 once, and it goes into 21 7 times. Okay? ab squared, ab squared, ab squared along this line can cancel out. Now I multiply straight across, and straight across I have an a to the 4th times 4. 4a to the 4th over 1 times 7, which is 7. Remember, there's a 1 here when you cancel that out. Okay? All right. The next one is a large multiplication, and you had to factor first and then do your minus 4a. Okay, I know this is going to be a shorter period, so I don't want to take all time on this top section because I want to get to the rest of the test. Make sure that you understand what they want you to do. Okay, if I look at this, first I already can do my bow tie canceling, right? But I can't bow tie cancel until I factor because I don't really know what is in some of these things, particularly if I look at a minus 7, that's prime, 5a squared is prime, basically, in when I think about it, because I can't factor it, right? So now I'm going to look at these two over here, okay, this one, and make sure that I can take some things out. I've got a squared plus 3a. When you have addition, you cannot factor unless you with only two terms, unless you use the distributive property. So this is a times a plus 3. Okay? This one up here, if I look at the numerator, I have a, and two numbers that give me 21, whose difference is 4, is 7 and 3, right? And my 7 is going to be the negative one because that's the middle term here. And this one has to be positive because I have to get that negative 21. Now I can start to cancel some things. I have an a plus 3 that can cancel out into a plus 3. Okay? I have an a minus 7 here that can cancel out along that line in a minus 7. I have an a that can cancel out into a squared, a times. And what am I left with? I have 1 left over here, right? Because when I cancel out, I really have 1 times the a, 5a, right? So this is equal to 5a on the numerator over, remember there's a 1 here and a 1 here. 5a over 1. Don't leave it like that. Write it as 5a. Okay? Now the division ones are done the same exact way, 5 and 6. Okay? Let's take a look at questions 7 and 8. And let's first of all look at the directions for 7 and 8. Okay? The directions say, find, now some of you wasted a lot of time on this. Find the LCD of each group of fractions. Okay? LCD. Least. Common. Denominator. Okay? All you had to do here was find the least common denominator. They did not tell you in these directions to write them with the numerators that would make them equivalent fractions, did they? Okay? So don't waste your time. If they tell you not to do something or just to do one part of it, don't think you're going to do the whole thing. All right? So now if I have some different fractions here, and let me do the second one because, or actually I'll do the first one, okay? Because we have 9 over 4xy. Notice they put commas between these, so they're not even asking you to add them. 5 over 3y and 1 over 12y squared. Obviously, I need to look at my numbers. 3, 4, and 12 all go into what? 12, right?
Yeah.
Now I take all my variables used in the highest power of any of them. So x is used and it is to the first power. That's the highest power used in all 3 of them. Y is my other variable and I take the highest power used, squared. Okay? And that's all you had to do for that one. So it should have been fairly easy.
The second one to me.
The second one was a little harder, right?
Really? That was so easy.
You thought so.
Easy.
The answer right there.
Okay. I don't care what the numerators are because all I really care about is the denominators here, right? I have x minus 7, x squared minus 7x, and x. Well, this one really, let's take a look at what this one right here is, because this is x times x minus 7, right? Doesn't that make sense that if this one is the product of these two, that this one, x minus 7, goes into this one, x times, and x goes into x minus 7, x squared minus 7x, x minus 7 times. So your common denominator here is x squared minus 7x.
Yep.
Okay? Now, when you have the next section that also says simplify, notice questions 1 through 6 said simplify and we're involving division and multiplication. Now you're simplifying involving addition and subtraction. Okay. Now, okay, you have to have a common denominator. You have to have an LCD to add or subtract fractions. Okay? Once you have that LCD, you just change them all into that fraction and then add or subtract. What you're forgetting to do is when you subtract, and I'll tell you why. Okay, number 10, for example, you have 6a plus 2 over a squared minus 36 minus, oops, that's a 2, 5a plus 3. Now this one, look at this, a squared minus 36. They have the same exact denominator. All I have to do is subtract the numerator from the first one. So I know that my answer is going to be a squared minus 36 here, right? Remember, when you have a binomial, now you forget this all the time, I have to distribute that negative sign, and here's the mistakes that you made. Oh, everybody's going, oh. 6a, this becomes minus 5a, which gives me 1a. Minus 3 gives me 2, minus 3 gives me minus 1. Okay? All right.
Oh, I get
Some
it.
people might have got it right. Okay. However, when you don't have the same denominator, you have to get a LCD first and then continue. But this is the mistake that everybody makes. They forget that that minus sign means I have to subtract both of these. Okay? The next section, write each expression as a fraction in simplest form. Again, these directions mean the same thing as the top 9 through 13. Okay? 14 and 15. So when they say simplify, period, and they have addition and subtraction of fractions, okay, and then they say write each expression as a fraction in simplest form. And they have addition and subtraction of fractions. These two directions are equal. Okay? When you are adding and subtracting fractions and it says to simplify, isn't the simplest form simplified? So they all mean the same thing. So the section on that was exactly the same. Now, where some people had some questions was write each expression as a fraction in simplest form. Questions 16 and 17. It means the same thing, doesn't it? Okay? They mean the same thing. So you had one subtraction, you had 3 fractions that had to be subtracted, and 2 fractions that had to be divided, so you changed those. And then they gave you another rule. They said divide. And here's the problem. N cubed minus 64 divided by n minus 4. This was the long division, polynomial long division one. Okay? In which case, you put the n cubed minus 64 inside the division bar and the n minus 4 out here. And you should have gotten n squared to make this n cubed. Okay, and then minus 4n squared. Okay, and remember we instead of subtracting this whole thing, which is exactly what you do in division, long division, we went and changed all the signs and added because it made it more sense to us. Now, there wasn't any 4n squared above, so when I add 4n squared, I get the positive 4n squared because remember I'm adding because I changed the signs. I have 0 n's. And if you want to put that placeholder in, you can. And then minus 64. Okay? N goes into 4n squared now, plus 4n times. Now 4n times n, Remember, you're multiplying back here like this. 4n times n gives you the 4n squared. Minus 4 times 4n gives you minus 16n. Okay?
It didn't say
It said to divide. Okay? And when it says divide, you can do it either way. However, how are you going to divide those two unless you factor it? And do you know how to factor this? I don't think you have the skills yet to factor that.
I'm supposed to do any of this.
It can be factored, but you have to do it this way. Because this is the only tool you have in your little toolbox to do this. Okay? Is the polynomial long division. Okay? So, have I done that? And now I'm going to change all the signs on my subtrahend, and I'm going to add. Okay? So I get negative 64 here, and I get 16n. Now n goes into 16n 16 times, and I get 16n. And 4 times 16 gives me minus 64, and those are the same, and I get a remainder of 0. So here's what you should have gotten when you do that division. Yeah, but almost only counts in horseshoes, okay? Now, it says, the next direction on number 19 says, factor this polynomial completely, given that x plus 5 is a factor. Well, if x plus 5 is a factor, use your long division and divide it. So what they're saying is, when they say factor, and they give you some polynomial, completely, now here's your given part. This is important. Given x plus 5 is a factor. What's a factor? If x plus 5 is a factor of whatever I'm going to write in this little spot up here, which is 2x cubed plus 11x squared plus 2x minus 15, what does factor mean? It means it goes into it evenly, doesn't it? 2 and being a factor of 4 says 2 goes into 4 evenly. So this goes into that evenly. And what do we know when we talk about gazindas? What operation is gazinda?
What's gazinda?
Goes into. Gazinda.
Oh.
Get it? You call them gazindas? I call them gazindas, right? Okay? So here we go. 2x cubed plus 11x squared plus 2x minus 15. And this gazinda this thing evenly, which means I better get a remainder of 0, right? And that's exactly what we're going to get, because we're going to actually factor this. So x times what gives me 2x cubed, 2x squared. Gives me the 2x cubed, okay? And now multiply this by 5, I get 10x squared, okay? Subtracting that out, I get 1x squared plus 2x minus 15. Well, if you think about this, let's just think about this a minute. What is this but x squared plus 2x minus 15? Doesn't that factor into what? X, 5, 3, right?
Yeah.
5 and 3, and I get a plus here and a minus here. X plus 5 goes into there x minus 3 times, right? So let's take a look at what we're going to get up here. X times x plus x gives me the x squared plus 5x multiplying. And when I subtract that out, I get minus 3x, or change your signs and add, right? Minus 15. Well, now it goes in, what? X times minus 3. Notice what happened here?
Yep.
What I put up there? because now I get minus 3x minus 15, and my remainder is 0. So this is what you get when you divide. So basically the divide directions were exactly the same when they say something is a factor of this polynomial. And I don't care what power you've got here. You guys can't factor those. You don't know how yet.
Yet.
Right.
You learn when you roll in.
And you don't learn that until Algebra 2. So what you've got to do is you got to use what you do have in your toolbox. Okay? You can't factor anything higher than the squares. Okay? And you can't factor an x squared plus a perfect square. Only x squared minus a perfect square. Okay? Now, we're going to redo this test.